Oh my heavens, 55 slides. We better get cranking. There are a number of kind of loops in Java, and we're going to go through each of these loops. For loops, while loops, do while loops, for each loops, and recursive methods. They're kind of organized in most elementally basic up to most complex and confusing. But we'll get to. So concept of a loop is that a computer program is going to repeat a mundane task without mistake ad infinitum. In other words, forever. It will never get tired. It will never complain, never go on strike, okay? One of the benefits of using computers is that they'll do exactly what you tell them until the end of time. So, once again, the 5 kinds of loops. So we're going to start with for loops. For loops are actually not the most basic kind of loop, but they are the, I think, easiest to get started with because they start with something we all know how to do, or at least we think we know how to do, which is counting. Counting. So look at this example of a for loop. You might recall these from your studies in your last year. You might recall the same exact for loop from your Arduino programming, but it works exactly the same way. This is a for loop that counts from 0 through 9. And we're going to look at the first line of the for loop because that's where it all goes down, all the information you need. So first things first, it starts with the word for. That's how the computer knows it's a for loop because it says for. For loops are counting loops. There are different kinds of loops. There are loops that wait. There are loops that count. There are loops that iterate or go over every element in a collection. For loops are strictly counting loops. So you tell them where to start counting, you tell them where to stop counting, and then you tell them how to count. Count by 1, count by 2, count by 4, count negatively, count down. You can do all those. So we call those 3 parts the start, the stop, and the step. So the example we have here, start counting at I equals 0, stop counting when we get to 10, and add 1 each time. So, yeah, question?
If you set a integer I equals, say 1, would it start at 1?
Yeah, so it would start, right, you could start counting at 1. There are good reasons we generally start at 0. I will get into that. But yes, you can start at any number. You can start at 300 and finish at 13,000. It doesn't matter. But in this case, we're starting at 0. Now to count, you have to have a variable that keeps track of counting. In this example, it's I. You might recall back in our study of variables, I told you not to name variables with a single letter. Well, this is the exception. It's okay to do it in a loop because a loop is generally a very short amount of code, so you probably won't get confused. When you have hundreds of lines of code, if you're using single letter variables, believe it or not, you will forget what they mean. So you want to use descriptive names. We were going to stop. So once again, that was the start. The stop, when I equals 10, we're going to stop. In other words, to keep counting, I has to be less than 10. And then we're going to count by 1, add 1 every time. That plus plus is a special code that means add 1. So technically, it's not start stop step. It's start as long as step. I say stop because I like alliteration, but in reality, it's start as long as step, which doesn't flow off the tongue quite as well. So I say start, stop, step. So once again, breaking it down even further, I equals 0. We're starting at 0. The variable I exists only in the for loop. You cannot use the I after the for loop because its life, its scope, is limited to that particular loop. The stop, or the as long as, I is less than 10. So each time through the loop it asks, what is I's value? Is it less than 10? If that question's answer is true, then it will continue looping. So when this statement becomes false is when it stops looping. And once again, we can think about counting. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I is less than 10. And then when I becomes 10, it is no longer less than 10. And then once again, I plus plus is our step. Plus plus means step. Computer programmers think they are efficiency experts. So whenever they can come up with a shortcut, even if it's a shortcut that only saves a single character, they think they're hot stuff. So It's exactly the same if we were to have the I equals I plus 1, where we're saying add 1 to I and then assign that result back to I. You can count down with I minus minus, and there are other shortcuts, I plus equals 1, which does the exact same thing. But we're not going to use those too often. Yes?
So if you want to do like kind of add 2, then you couldn't do like I plus plus right now. You just do I equals I plus 2.
Correct. Yes, you do I equals I plus 2 or I plus equals 2.
Okay.
Yeah, there is no I plus 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 plus. That would not work.
Got that.
Yeah, no, you can't, because the plus plus has to be attached to a variable. If you put another plus plus, that's attached to the first plus plus, and you can't increment that. I don't know. You could put a plus plus in the beginning and a plus plus at the end, but that would be ridiculous. Again, if you did that, you would get laughed at by all your peers. It would be publicly humiliating. And we wouldn't want that. Okay, so I equals I plus 1, of course, in math, looks like a nonsense, impossible statement, but in coding, it is possible through the magic of sequence. And the magic of sequence, it's a step-by-step procedure. First, you're adding 1 to whatever I was, and then you're taking that result and putting it in the container that you just used the value from. So it's not that complicated. And a word about the assignment operator. This is kind of an aside. We've talked about the assignment operator before, but one thing that you can be sure of in life, there's very few things you can be 100% sure of in life. One of these things is that if you see a single equal sign, the thing on its left must be a variable. And the thing on its right must be a value. Okay, if the thing on its left is not a variable, your code won't work. Yeah?
So if it was I equals I plus 1, would that be nice?
If you put I equals I plus 1, you're asking it, that's a question. The double equal sign is saying, are they equal?
Okay.
The single equal sign is saying, make them equal.
Okay.
So, and they call that a gotcha because it's an easy to make mistake while coding. You might only hit it once and mean to hit it twice, or you might accidentally hit it twice when you mean to hit it once. So Java is pretty good. Java won't let you make that mistake most of the time. Yes, there's a wasp. But as long as we're here on the ground and it's up there on the ceiling, we're good. So if any of you start flying, or if the wasp decides to start walking, then we got issues, okay? All right, moving along. So this is a general loop design pattern. You're going to see this I call it a design pattern because it's very common and you should really kind of ingrain it in your computer programming memory. You're always going to start at 0. You're always going to go strictly less than the number of times you want to count, and you're going to plus plus. And there are really good reasons to use this. Most of them have to do with arrays because we know array indexes start at 0. And they stop at 1 less than the number of elements. So if we go strictly less than the number of times we want to count, we are always following the same pattern. So this is your general design pattern in action. I equals 0, I is less than 10, I plus plus. And this will count 10 times, being 0 through 9. So what I recommend doing is take this general for loop design pattern, and I'm not exaggerating when I say you will use, if you enter the world of computer programming, you will use this design pattern virtually daily. So you should probably find a way to commit it to your memory. I recommend tattooing it backwards on your forehead. Okay, on your forehead so it's visible, and of course backwards. You could read it in a mirror. Exactly. Yes. So we're communicating. That's good. So you understand me. So once again, there's that same code with the output. And notice in this example, I actually started the I before the for loop so that I could look at the I after the for loop. This is not typical. I only did it in this example so we could peek at the I afterward. Because remember, the scope of the I would have been just the for loop. But as you can see, after the loop, I is 10. So it asks, is it less than 10? When it is no longer less than 10 is when we kick out. Questions? So I is 0, I is less than 10. our body of the loop executes 10 times, adding 1 every time, and then it's evaluated before the iteration so that afterwards we're at the 10. Yes?
Why does the very last time equal 1? Like, how does I'm just like confused on how that last thing.
I don't know if I follow you.
Like, how does the plus I know that the loop is over?
You're talking about this?
Yeah.
So the for loop is from this brace here down to this brace here. So anything between those two braces will execute over and over again until such a time as the stop clause is no longer true. So I starts at 0, and we print 0, and then we print potatoes. Then I plus 1, I plus plus happens. I's value is now 1. And then it says, is 1 less than 10? Yes, it is. 1 potato. I becomes 2. Is 2 less than 10? Yes, 2 potatoes. Fast forward to 9. Is 9 less than 10? Yes, 9 potatoes. Add 1. I's value is now 10. Is 10 less than 10? No. Now we're done with the loop, and we skip to this line here.
So then how does that plus I at the bottom read that you counted 10 times and now it has that?
Remember, I is a container. We're just looking inside the container here. So the container started out empty. Then we put a 0 in it. Then we added to it a bunch of times in a row. And now we're looking in the container after the loop is done. Remember the concept of sequence. 1, 2, and then these lines happen over and over again. And then we are down to 3, which is this line here. Okay, so the truth about for loops is whatever you put in the front here happens once, and it happens first. Whatever you put in between these semicolons happens before each loop iterates, and then whatever happens in the third clause happens after each loop. Okay. Any questions about for loops before we move on to while loops?